Welcome to LNP Renewable System Tutor. Today we are going to discuss some of the basics of electrical part 22. So this session we had classified in 25 parts. If you missed out anything, no issue. Please subscribe to the channel and press the bell icon. And in our channel we had created a playlist. So by going into the playlist you can able to watch all the 25 parts which we had discussed. So in our discussion we might be using so many abbreviations and the short forms. If you have any doubts, please refer to this. What are the things that we are going to discuss today in this part? So we are going to discuss what are the different type of charge converters for the electric vehicle supply equipment, and what are the different charging levels for different electric vehicles which is already in the industry, and how a AC and DC charger looks like, and how J1772 communication signaling circuit works, and how a Delta, Allen Broadley, Siemens, Exegium chargers and stations looks like. So this is a charger type. If you're planning for a fast charger, the charge connector can be CCS if it is minimum 50 kilowatt. Okay, and rated voltage can be from 200 to 1000. Okay, and if you're going for CADIMO, so we can use the rated voltage up to 200 to 1000. If you're going for type 2 AC, minimum it should be 22 kilowatt. Okay, and if you are going for a slow charger type, then you can use Bharat DC 001, which we can use up to 15 kilowatt, and the rated voltage is 72 to 200 volt. And if you're going for a Bharat AC 001, you can use up to 10 kilowatt. It is a slow charger, so you can use with a 230 volt rated voltage. So as we told earlier, in the fast we have number of charging ports will be only one, but when you go for a slow charger, that is Bharat AC, that is 10 kilowatt type, there you have 3 charging port provisions. As we told earlier, we have so many electrical vehicles available in the industry. Okay, we have Toyota Prius, so its driving range is from 4.4 kilowatt. We have Chevy Volt, which is 16 kilowatt hour, and we have BMW i3, which is 22 kilowatt hour. We have Nissan Leaf, which is 33 kilowatt hour. We have Chevy Bolt, which is 60 kilowatt hour. We have Tesla S85, which is 90 kilowatt hour. But all these electric vehicles, we can use level 1, level 2 and level 3 chargers. Most importantly, for Toyota Prius and Chevy Volt, we can use the level 3 DC power charger. We can use level 1 and level 2, both are AC. So one is 120 volt AC and the other one is 240 volt DC. It is 15 amps and the other one is 30 amps. Okay. But for this BMW, Nissan Leaf and Chevy Bolt and Tesla, they have options for doing AC charging as well as a DC charging. And most importantly, when you're going to use a DC fast charger, you need to charge your vehicle only up to 80%. Okay, and if you're going for using the DC fast charger, BMW 80% will charge in 30 minutes. Okay, whereas Nissan Leaf it will charge in 20 minutes. And these are the different types of chargers. This is how it looks like. As you can see, so Tesla had designed a charger for Japanese standards and even for European standards also they had designed it. Okay, and when you go for combo 1 and 2, in that one you will have a AC charging provision as well as the DC charging provisions. So this is how the level 1 AC chargers looks like. We have AC pins, we have a communication pin. This is through this pin the communication is getting established with the electrical supply equipment of the electric vehicle. Okay, and we have a EV socket and ground pins. This is used for latching. And this is how the DC fast charger looks like. So in the fast charger we have the high power charging pins and we have pins for communications. And we have a grip and cable and we have a latch release button also. We have a lever also. And if you're going for a combo AC charger which has both AC and the DC, so this is how it looks like. These are the low power charging points. This is the communication detection pins. And this is most importantly J1772 combo socket. Here high power charging pins will be available. So this is the Tesla charger which we have provision for AC and the DC also varieties are available. This is the power pins and this is the connection detection pins. And we have communication pins also. So this is J177 signaling circuit. So it is nothing but the pilot which establishes the communication between the electric vehicle supply equipment and the vehicle. So in the electrical supply equipment, we'll have a electrical supply equipment controller, and in the controller we have a J1772 signaling circuit, because with the help of that only we can able to read what is happening in the vehicle. So in the vehicle we have a vehicle inlet and a vehicle controller. So as we see, we have state of operations with this communication. Say for example, if the status is A, it means it is in the standby mode and the voltage is plus 12 volt. Okay, if the status is B, then the vehicle is detected. Okay, and if the status is C, it means it is ready for charging. Okay, and if status D, then we need to keep the vehicle with ventilations. And if the status is E, it means there is no power, it is shut down. And if you got status F, it is an error. So in the control pilot, we have a current limiting feature. It describes the maximum current that is available via the charging station with the help of the pulse width modulation. Say for example, with the 16% pulse width modulation, we can have a 10 amps maximum. For a 25% pulse width modulation, we can have 16 amps maximum. For 50% pulse width modulation, we can have 32 amps maximum. For 90% pulse width modulation, we can have a fast charging option. So proximity pilot. So what is the purpose of this proximity pilot? So it is shown J1772. It describes the switch S3 as being mechanically linked to the connector latch release actuators. So during charging, okay, it connects the proximity pilot with the PE loop via S3. Okay, and when opening the release actuator, okay, this 330 ohms resistance is added in proximity pilot, which gives a voltage shift on line to allow the electric vehicle to initiate the control shutdown off prior to the actual disconnections. So P1901 is a Powerline Communication. Okay, so when you had a plan to do Powerline Communication, specifically it should comply IEEE 1901 standards. So as we shown earlier, this is how the Delta AC charges looks like, and this is the DC charges of Delta, which is in the range of 25 kilowatt to 150 kilowatt. So Delta Electronics India is providing site management system. So with the help of it, we can integrate and see where are the charger providers available. Okay, even for the energy management purpose also we can use this Delta management service systems. Okay, it supports in diverse output of the charging information and user profile records. It also enables the electrical drivers to collect their charging history and real-time charging stations. What are the main benefits? So this is how the ABB charger looks like. So it took 30 to 120 minutes for charging. Okay, we have three options. It has a combined charging system, and it also has a type 2 AC and cadmium too. And this is an example of a Siemens charging station. So maximum it can be used for a single phase AC systems. So Exicom is a new Indo-Australian origin electric vehicle charging station. Thank you so much. Please subscribe and press the bell icon. If you want to know more and learn more, you can contact us. We can provide the contact details here. We, LNP Renewable System Limited, we provide PLC programming along with the certification of ISO 9000 and 2018 for Siemens, Allenbroad and Delta PLCs. And if you had a plan to work in the GCC country, you're from EEE, ECE or electronic instrumentation engineering background, you want to know related to the automation industry, we are providing training in the building management system and the building automation control system. And if you had a plan to put fencing for your agriculture farms, you are providing solar fencing as a kit. Okay, we are also providing solar on-grid, off-grid and hybrid application, design, installation, testing, commissioning, consulting, training supports. Also, if you had a plan to learn the electric vehicle basics along with the certification, then you can contact us. We have provided the contact details here. We are also providing training in the access control systems as well. Thank you so much.